Now you guys get to see me. Oh, damn, I need a haircut. Okay, so today I'm preparing for the Timaeus. So you get to see me try to crack behavioral and like explain whatever on earth I've been doing for the past, I guess, year, 2 years. So yeah, hopefully this works. So we are outside today, which is cool. Alright. Yeah, okay. So, hi, I'm Ayush. I'm an undergrad studying computer science and Hi, I'm Ayush. I'm an undergrad studying computer science and philosophy at the University of Illinois at Urbana-Champaign. I've done mainly research engineering work here at the university. For the past year, I've been doing Mech Interp research, both under a professor and on my own time. With the professor, I developed a system to create linear probes based off the embeddings found inside LLaM and other open source models to then determine what types of truth is present in the model. I've also co-founded OneSpace, which is a document editor platform where I've built out the infrastructure to store hundreds of thousands of nodes and also a RAG to query and retrieve those nodes very quickly. On the research side, I've done more truth direction stuff where I design probes once again, but I've also done low-level systems work where I've been working on distributed systems and writing failure detectors that have been used in industry at places like HashiCorp. And I've also developed more traditional just model work on writing a convolutional neural network in CUDA with a bunch of different optimizations. I'm really excited about Interp's mission and Timaeus' mission more broadly because I think like trying to understand how models learn is part of the way that we actually crack what happens to them. And the learning process, I think, should translate to future models as well. Like one of the big bottlenecks in Mech Interp is it doesn't really translate that well to future architectures. But I think the way models learn, there have to be some similarities in future events because there's similarities already with how we learn to how a model learns. So I think it's very interesting, and I think research engineering is sort of the role I want to play since I want to get more and more experience designing these systems. Like I've done a lot of research myself, and so I know how difficult and annoying it is to build the infrastructure to actually just test your question. So I want to gain more experience doing that. Hi, I'm Ayush. I'm a senior studying computer science and philosophy at the University of Illinois at Urbana-Champaign. And for the past year, I've been doing mechanistic interoperability research, both as on my own time, my own projects, and also under a professor at the university. As part of that research, I've built a lot of pipelines and tools in engineering work. So for the professor, I built out an entire PyTorch pipeline to actually train linear probes on the embeddings pulled from a variety of open source models and change the types of probes that you can train. I've also done more traditional infrastructure work at OneSpace, which is a startup I co-founded where we're building a document editor for lawyers. And there I've built a system that can store hundreds of thousands of nodes inside JSONs. And we have a RAG that can query them quickly. And so users can just ask questions about whatever they've noted on. And on the research side, I've done roughly 4 to 5 Interp projects where I've built things from translating string vectors from one model to another, all the way to doing trying to train SAEs on SAEs on SAEs ad infinitum. But I've also done more traditional systems level work, such as building out failure detectors for a distributed system of 10 VMs that is used in industry today in places like HashiCorp, as well as writing a convolutional neural net in CUDA. I'm really excited about the mission of development interpretability, and so I'm really excited about working at Timaeus. Because I think one of the issues with MechaInterp right now is it's not really translatable to future models. But I think DevInterp kind of is. Like the way we train and understand, the way a model learns is very similar across different types of models. And even if it doesn't exactly translate, I think there's more of overlap in the DevInterp space than in other places. And so I think Timaeus, the work they're doing in model complexity and data attribution is really interesting to me. Hi, I'm Ayush. I'm a senior studying computer science and philosophy here at the University of Illinois. And for the past year, I've been doing mechanistic interpretability research, both on my own and under a professor. under a professor, I built an entire pipeline to generate linear probes based off of embeddings that we pulled from 3 to 4 open source models. And we have the ability to swap out different probe methods and try to analyze what's going on, what type of truth is present in these models. I've also done work at CCC Intelligent Solutions, where I was a data scientist, and I was doing fine-tuning of large models, of 40 million claims, to try to see can we improve model accuracy and figure out these issues. On the more system side, I've worked on distributed systems and built a failure detection system using a protocol that is used by HashiCorp as well, an industry standard. And I've also done work on traditional CUDA convolutional neural network stuff. I'm really excited about looking at Timaeus since I've seen that mechanistic interpretability is very interesting, very fun. I really enjoy doing it, but it's not translatable to future models. But one thing that is translatable is sort of the way that data affects a model. And so the data attribution part, the SLT part of the sort of dev interp field that Timaeus is a part of, I think is something that is robust to changes and to advancements in model architecture. I did a project recently where I tried to translate string vectors from OpenAI GPT-2 to Whisper, just to see, like, do they have the same representations? And honestly speaking, some of them succeeded, which is crazy. It sort of implies, right, that there is a shared reality that these models are learning, and that data is a core component of that. So I think data is a very interesting place to play in the field of interp.
Oh, that went so bad.
Hi, I'm Ayush. I'm a senior studying computer science and philosophy at the University of Illinois at Urbana-Champaign. And for the past year, I've been doing mechanics interpretability research, both at the university and on my own. For the university, under a professor, we were analyzing the existence of truth within LLMs like Llama, Gemma, and such. And so for that, I built a PyTorch pipeline to test a bunch of different kinds of linear probes on the embeddings that we extract from those models. I'm also a co-founder of OneSpace, which is a startup trying to build document editing tools for lawyers. And for that, I've built a note-taking system that can handle hundreds of thousands of notes and thinking and able to query them fastly and efficiently for use in a RAG, so users can search over their notes really nicely. In terms of more systems level work, I'm building a distributed systems this semester for failure detection and for distributed file systems. The failure detection protocol I wrote is used. I implemented is used at top companies like HashiCorp as well, like in the industry. And I've also done work on traditional ML, such as designing a convolutional neural network written entirely in CUDA. I'm really excited about the mission of Timaeus, and part of the reason why I'm excited to work there is since I've been building out Mech projects for the past year, like translating string vectors, with SEEs, all the traditional stuff. But I think one of the issues is that sort of data is Mech is not translatable to the next architecture, is what it feels like. But data attribution and phase changes and these sorts of like emergence properties seem like they might. I think especially data is definitely transferable. So I want to work in a space that will push farther, but I'm really deeply in love with interpretability. And so I think to me it's sort of the perfect fit of interp that is scalable to other types of systems when we eventually inevitably move past transformers. Hi, I'm Ayush. I'm an undergrad studying computer science and philosophy at the University of Illinois at Urbana-Champaign. For the past year, I've been doing mechanistic interpretability research both under professors here and on my own time. For a professor here at the university, we were analyzing what types of truth is embedded inside of large language models. And so I developed a pipeline to test different types of probes on the embeddings we've collected from those models. I'm also a co-founder of OneSpace, where we're building out a document editor for lawyers. And for that product, I spent time building out a data storage system that can handle hundreds of thousands of notes that a user can query and access really quickly for use in sort of an LLM chatbot RAG. I also have more traditional sort of systems experience. I've built out training pipelines for training convolutional neural networks in CUDA. I've done work in distributed systems where I've implemented failure detection protocols that are used at top companies like HashiCorp. And I've also done work at CCC Intelligent Solutions, where I was a data scientist working on doing model fine tuning of a data on with a data set of 40 million samples that has actually improved the accuracy of this model and made it classify 3 million more accurate claims per year. I'm really excited about the opportunity to work at Timaeus because I think Mechaturp is sort of at a point where it's not exactly transferable to future model architectures, but data really is. Like the way data impacts training is sort of really present and omnipresent in all types of training. So I want to work in interpretability, but I want to work in interpretability that is extendable, which is what Timaeus offers. Hi, I'm Ayush. I'm a senior studying computer science and philosophy at the University of Illinois at Urbana-Champaign. For the past year, I've been doing mechanistic interpretability research under professors here and on my own time. I've built out a PyTorch steering pipeline to look at. I'm Ayush. I'm an undergrad studying computer science and philosophy here at the University of Illinois. For the past year, I've been doing mechanistic interpretability research and specifically looked at this existence of truth within large language models. For that project, I built out an entire PyTorch steering pipeline to train different types of linear probes and see what types of truth emerge from them. I've also done work in more traditional systems where I've been building out distributed systems and failure detection methods to see if a server crashes, what's the rejoin process, how can we fix it? And these systems are used at top companies like HashiCorp. I've also done traditional ML training where I've written a constant alert in CUDA. But I think like I think one really interesting thing is I've also spent a ton of time doing the actual research myself. I'm Mahesh. I'm a master in computer science and philosophy at the University of Illinois at Urbana-Champaign. For the past year, I've been doing Mech Interp work, both under the university and on my own time. One project I've worked on is I built out a PyTorch steering pipeline, training pipeline, to look at the efficacy of linear probes on llama and other models. So we trained a bunch of different linear probes and we had to analyze them and see do they detect the existence of truth inside these models. I've also done more traditional systems work where I've been developing distributed systems that can handle failure detection over 10 or like 100, 200 different VMs, and can we see if we can rejoin the VM back. And this is a protocol that's used in places like HashiCorp. I've also spent time doing fine-tuning work in CCC intelligence solutions, where I fine-tuned fraud models and increased the amount of accurate fraud detections by over 3 million claims a year. But I think I'm really excited about the role here at Timaeus, since I've been on the research side for a while now, and so I understand like how critical it is to build good research infrastructure. And I think to work on that at a place doing Interp work, which is sort of what I'm really happy about, is where I want to be. Hi, I'm Ayush. I'm a senior in computer science and philosophy at the University of Illinois at Urbana-Champaign. For the past year, I've been doing mechanistic interpretability work, where I've been designing, training, and research pipelines to analyze the existence of truth within large language models. So this was a pipeline that could train different types of linear probes and see can we find something inside of LLMs. I've also spent time doing traditional systems work, where I've been building out distributed systems for failure detection and for doing the log querying on 10 multiple VMs at once. I've done work on traditional ML, where I've developed CUDA models to train convolutional neural networks. And I really am excited about sort of working at Timaeus, since I think it's really important to make sure that Interp is sort of extensible. And that's what Timaeus offers. This data approach means that it will extend beyond just like the current state of the models. And so I think I want to work in interpretability, but in interpretability that extends, that is robust. And past that, I've been developing a lot of research. And so I think research engineering is something that's really interesting to me because I understand how annoying it is to sort of set up the infrastructure to then actually answer your question. But the work test that Timaeus gave was super fun. Like it's made me actually rethink the way I was going to do my own research engineering pipeline and actually think about what are the types of actions I do day to day. And so working on that at an industry level is really exciting to me. And I think like I have experience as a researcher, and so I have an understanding of sort of what are the things a researcher would want, since I know what I want whenever I'm doing my own research.